using. I'm always saying that's position so that we don't confuse the idea of the index concept with the position in the array. So I'm always calling that thing the position.
Oh, okay.
Right, just to keep us from confusing those two terms. I'm calling index the concept that we're implementing, and the position is that little number, right? So what we're going to end up with is this, right? We're going to end up with an index class that takes in a k, but what are the nodes going to look like? Public class node, we're going to have normal nodes that are going to take k's, right? And what are those going to have in it? Right, let's flesh these out a little bit so we see. That's going to have public k data, right? You guys help me out a little bit here. What else is in a normal node?
Left and right.
You got to have a left and right, and that's going to be a node k left.
Should the node class be private?
No, the node, oh, sorry. Yes, the node class will be private. Thank you. And then we're going to have public node k right. What else is the node, a normal node, going to have?
A same node?
It's going to have a same node, so we're going to have that too. Yep, that's one thing it's got to have. Actually, we'll come back to that in a second. But what else? We got to have two pieces of data, right? We got to have
next
value.
I mean
It's going to have public int position.
or position. Yeah.
Right? Make sense? But now, how about this other node? I'm going to call this a dupe node. Does it even need a generic at all?
No, it just needs a position and same, I think.
So it's going to have a position and it's going to have a same, but guess what? These aren't node Ks. These are dupe nodes. These are dupe nodes. Not generic, doesn't need to be, because it doesn't have any keys. This thing is only going to point to a dupe node, and then dupe nodes are going to point to each other, right? They're going to point to each other.
I'm still confused why we're not just storing all of the, like, why aren't we storing multiple positions in one node instead of?
How are you going to do that?
You can just have, instead of public int position, you can do public int array position and just return multiple positions.
But then you're going to have to go deal with expanding the array all the time. Then you're going to have all that array list problem, right? And since we're working with references in a dynamic allocation scenario, I think that's not in the spirit of this actually, right? I think since we're using references to build nodes and pointers to things, that actually a linked list is more in the spirit of this.
Okay, so why not just use a linked list of integers then?
You could, but why have the overhead of yet another object when all we need to do is one pointer, right?
But it's not just one pointer. I don't understand.
I mean, literally, to walk that list, you're literally only going to ever do next. You're never going to do contains. You're never going to do get from the middle of it. You literally just need a way to walk it. And so I think the amount of code that we would actually be pulling in is so little compared to that it's not worth having a whole separate linked list data structure.
But it's not separate. It's the same. It would be, I mean, like I'm just asking, why are we re-implementing linked list if we're?
Because we're implementing one line of the entire thing, in essence, right? We're literally implementing like one line of code from that entire class, right? We're not duplicating anything out of it except one line. Is it really worth the overhead of having to instantiate that whole structure, right? When we really need one line of code out of it. And that is current equals current.next. Right? It's literally a loop. So is it worth the whole data structure? And again, if we're building our own, why don't we just build our own, right? Like why go get other data structures when we're doing things that are practicing with data structures, and we need like literally so little out of that class that I just don't see it as being worth the overhead.
Okay, so you're saying don't use the linked list class then?
Yes, I'm saying don't use the linked list class.
Okay.
We didn't use it when we made a linked list. Why would we use it now, right?
Oh, I thought that that project was showing us how to make a linked list
Yeah,
rather than,
yeah, it is, and it was, but since I mean, we're really making very similar thing here, right? So, I mean, literally, if it were much code, if we were re-implementing much of it, I would say absolutely, right? But I think in this case, it's just not worth that extra little bit of stuff when all you need to do is be able to plop things at the front and walk the thing. But yes, I understand your point. We could certainly do that, right? That would be one option, is instead of doing this. But then the other thing, Alex, the other overhead would be you can't make a linked list event. So then now you have to go linked list integer, and then you'd have that object overhead and the boxing and unboxing on top of everything else. And now you've gotten way less efficient, right?
okay.
Because now you've got a generic where we are able to literally do, right? We're able to do just the primitive, and that will save us some overhead as well. Okay. Yeah, Bjorn, go ahead.
Should the dupe node class be private?
Sorry, yes, that should also be private. Thank you.
They both be static as well.
They both can be static. That's right. Private static class. Thank you for noting that. Private static class. Node.
Did you
and
put
here-
the dupe node class in the node class?
No, because in the index, you're going to have to create those separately, and that would make you have extra code to do that. You'd have to create a node in order to create a dupe node, and the code would be a little funny. You could do it, but you're going to see the code can get a little funny. Yeah. So getting the idea here, folks, about how we can start working on that index. The index doesn't need a lot of methods, right? You don't really have a lot of methods. So, you know, what we're talking about having here is, here's a list of the methods that I have in mind, just to give you an idea. In the index, I have add, which I could also call put, right? So really you have a put, and I actually have two of them, but I'm not sure that you need two adds, right, or puts. I have a get position data, right, which is going to walk the whole tree and return an integer. Let's see what else. And I think that's what I have. Like literally, that's what it is. In fact, I will even give you, since we're getting close on time, I'll actually give you the signatures of these methods that I have. So this is what I have in mind. This isn't going to be front, it's going to be root, right? So here's exactly the methods that I have, right? I have an index, I have public index, here's my constructor, and it's going to look like that, right? There's the signature for that. I'm going to have put or add, and that is that you give me an E. So I'm going to, let's see, how should I say this? I'll do it in terms of UML. I'm going to have put where you give me the data, that's a K, and then you give me the position, that's an integer, but it's going to be an int, right? Not a wrapper type. And then I have an overload for that, but I don't think that's worth worrying about. And then I have get position data, and that's going to take nothing, and it's going to return an integer array. That's what I got in my index. You could do a get, right? You could say get, which would take in data, which is a K, and give you back a V, right? Which actually is going to be an int, right? Integer. So I would say that is all that you need in your index in terms of client services. For us right now, that's all we need to have. So you're making an index, which is a special case of a tree map, which is a special case of a binary tree, or a different case of a binary search tree. You're making only these methods, and then the methods that are in the wearable manager I've already given you. The wearable class is actually very straightforward because it's just a very standard class to just hold a bunch of data, right? It doesn't have anything that interesting in it. So in essence, I think I just gave you most of what you need to design this. Okay. All right, what questions do you have? I want to see if there's anything else that I want to talk about slide-wise, but what questions do you have right now?
Could you